So hello, everybody. Today we want to talk to you about artificial life. Artificial death. And it's work by Lund, Cesare, Carissimo, and myself between ETH in Zurich and Tokyo University. And so I'm going to make a claim here. I'm going to say there is no life without death. And I think perhaps many of you would agree this is also sort of a topic in philosophy and religion where life and death are kind of considered together. And we also have artificial life, right? But what is artificial death? Do we have something like that? What could it mean? Can an algorithm even die? A lot of you are probably working with multi-agent systems. And what does it mean for an agent to die? Can it even happen? And so perhaps also you're aware of ChatGPT-3. Some people are claiming ChatGPT-3 is conscious. If it's conscious, perhaps we could also claim that it's alive. And then if it's alive, can it die? What does it mean if it dies? And so we will not answer any of these questions here. Probably they're quite fundamental questions. But what I'm trying to give you here is the motivation that we got for what we did. So maybe let's be a bit more specific. So how can we personally understand death at an individual level? A lot of us might have had some experience with that. And it's certainly a very strong influence on us, a very strong signal. So we, of course, have to deal with our own mortality as well as mortality of others. And there is a lot of culture around that. There is a lot of different ways of dealing with death, different rituals, different customs, often different in different cultures, different funerary rites. And one of these things that seems quite common to all cultures is the sort of sharing of stories about death and about those who died. And this could be on a larger historic scale when we learn history, but it could also be quite personal when we learn about our family, our ancestors, our family history. And actually, these stories that we pass, they also have a bit of perhaps a global influence, as they can really outlive those who died, certainly, and us, and just travel through generations. And of course, when we're talking about death, there's also this more global scale, an evolutionary scale, where death also plays a role. And it can be understood as removing certain genes from the gene pool, as well as returning matter and energy into the system, and in both those ways sort of affecting future possibilities of becoming. And so perhaps this has been a bit abstract so far. So let me try to give you a concrete example. And so, like, has anybody ever eaten this mushroom? Any mushroom people in the audience? No, no. Okay, that's good. Like, I think if anybody had eaten it, you probably wouldn't be here. It's a very deadly mushroom, so you're not supposed to eat it. Actually, in some places, I think this is Australia, they even put signs, warning signs, don't eat that mushroom. And it's quite interesting. I'm going to give you perhaps a bit of a personal example. So I'm from Poland. In Poland, we have this long-standing tradition of mushroom gathering, mushroom picking. I figure in a lot of countries as well. So it's kind of a family thing. People will go into the forest in the season in the fall, look for mushrooms, pick the right ones, bring them home, prepare them, and eat them. And this kind of mushroom also, it's a death cap. It also grows in Poland. And somehow, usually people don't end up picking it, don't end up eating it, even though it's supposedly quite similar to some edible mushrooms. So how that does come about, people not eating this mushroom? And I think I could make a very good, almost a proof that someone must have eaten this mushroom at some point. It seems like the only plausible way in which we could have learned not to eat it. So, perhaps thousands of years ago, the first hunter-gatherers would come across this mushroom, and some people would eat it, then they would die, and that would induce such a strong signal, such a strong reaction in their conspecifics that they would sort of remember not to ever eat this mushroom again, and they would perhaps pass this as a story throughout the next generations. And this is exactly what we're kind of interested in modeling in our work, this sort of intergenerational knowledge transfer motivated by death. And what would be some appealing properties of such a model? So for one, as this sort of knowledge about death and dangerous situations starts growing, we would expect a certain increase in the lifetime of our agents, as they don't eat the mushroom anymore. And in the similar, we also have another feature, which is an attention span, right? So if you consider the mushroom example, I'm not that great at mushroom picking, but I've been shown this mushroom a few times. And then if you go mushroom picking with someone who's very specialized, who's perhaps a biologist, they will give you a lot of details about that mushroom that you might not even be able to retain, right? You might not have enough attention to kind of keep all that at the same time in mind. And so there is a certain limit to what you can really store. And then in the similar vein, your memory is limited in a larger sense. And so if you are getting a lot of information, some old information might get sort of deleted. And this perhaps is quite relevant today as we're living in this very information-rich world, kind of getting information from everywhere, not being sure which ones are important. And actually, there have been some studies in Amazon, especially, about the indigenous tribes' knowledge about edible plants. And it has been discovered that this kind of knowledge is seemingly decreasing. And I would expect a very similar result in Western societies. Okay, but so these are the properties we're looking for, and how might we get those properties?
So we decide to use reinforcement learning with a Markov decision process. Inside it, we add Q-learning. And the Q-learners are expected to use intrinsic novelty rewards. So it's not something I think most people are familiar with here, but rewards are given on the basis of visiting of certain states. Still, where does the death come in? The mushroom analogy leads us nicely to understand how this might be. Suppose we have a grid. We are moving around this grid. We can go up, down, left, or right. Our agent is the little circle. And in this grid, there are some death states, some deadly locations upon which the agent would actually die. So in typical reinforcement learning, let's say you have a neural network that is trying to play a Mario game. In a typical reinforcement learning setup, if as Mario you step on the mushroom, well, you might actually grow, but let's suppose the mushroom kills you. If Mario dies, the neural network is just spawned back to its initial state where it can try again. It has complete access to everything that it had learned to that state, complete access to all the weights of its models. It has complete access perhaps to the memory buffer where it has been storing the experiences that it was using. So that's where our twist comes in. We suppose that instead of being replaced exactly by the very copy of the agent that died, that a child comes in and is born into the system, and this child does not have access to everything that its parent had access to. In particular, the child has access to the memory buffer where experiences were stored, but it has access to a subset of the memory buffer. We call these the death stories. So what exactly goes into a memory buffer? It's the experiences, these tuples where a state, an action, and a next state are saved alongside a reward, in this case, the intrinsic novelty rewards. We could think of a collection of experiences, sort of a chain of experiences that follows in time as a story with a certain length. So we can have death stories where the very final experience is the death, but there may be experiences that led up to the death. So a single death story would be, I ate the mushroom. The longer death story could be, I was with Marcin in Poland. We went to the forest. We entered the forest and saw a colorful grove. In this grove was a bright green mushroom. I ate the mushroom. So our agents will be sampling when they are spawned into this new environment from the experiences of their parent. That's all it is. To test how this, if there is any effect of this, if we get anything death-like in this experience and transmission, we first look at a very random case. So suppose that the parent gives a random selection of its experiences to the child. What we see here on the screen is that very grid world. The white X's are locations where agents have died. These are averages over many runs. And from left to right, we see agents in the very beginning of their learning, agents somewhere in the middle of their learning, and agents at the end of their learning. So we see here in the color gradients that the agents at the end of learning haven't really visited that much more of the environment. So they haven't been able to explore, they haven't gathered the novelty rewards in many locations of the space. Most of it is dark. What we also see is that the last agents and the middle agents and the first agents all seem to die in somewhat similar locations. So again, we were sampling random rewards, and in these random rewards may have been some of the death experiences, but they were not guaranteed to be. Another way to see these results is just by measuring the lifetimes. Here we, again, are averaging over many runs, but we see that over the course of learning, the lifetimes do not really improve. We have a few different colors. These represent some sizes of stories. So a story of size 1 would just be the death experience, but we also see no difference in this. Now we look at the case where we do share these death stories. So at the end of the lifetime, the parent will share the story of its death, but also the story of the death of all of its ancestors with the child. We clearly see here that the final agents have explored much more of the environment. So that's a good sign. We also see that if we compare in time, agents do seem to be able to avoid the deaths of their ancestors. We see that because the white crosses do not always appear in the subsequent plot. If we again look at the lifetime plots, we notice that clearly there's a positive effect on these lifetimes. These lifetimes increase over time. And we also point out, so this was sort of one of our first conditions for appealing conditions for the model. Second condition for the appealing properties of our model was this attention factor. So what do we mean by that, and how can we see that here? Well, when we share larger stories, so stories of size 7 or 15 in this case, we don't see a direct benefit on the lifetimes. Why might that be induced? That might be induced because a long story contains many experiences which aren't actually related to the death, and in our simple model, it is only really the death experiences that will save you from it. And finally, we also see somehow a signature of forgetting. By the end of learning, for the larger stories, the lifetime benefit tapers off slightly. Agents don't have an infinite capacity of remembering. Their memory buffers are limited. And therefore, if some death experience is overwritten by something else, that will no longer be beneficial towards the end of the lifetimes. So that summarizes our main insights. On the one hand, we see that the child improves on the experiences of the parent. And on the other, we get the less intuitive, the less obvious, immediately obvious result that more information may be harder to learn from. So that's it. But we'd like to leave you with one more thought, that perhaps thinking of things in these terms, in the terms of death, where we are surrounded by all sorts of artificial devices, but not exactly artificial life, perhaps, but that these sort of insights may already be applicable. We all carry around smartphones. They learn a lot of things about us on a daily basis. They store all this information, but we also change these phones on a regular basis. Could it be that when we change these phones, we shouldn't just restore them completely from the previous phone? That it is only a subset of things that we should carry over. What is this subset of things that we should carry over? These are some open questions, but that we wished to leave you with. Thank you.